Hello everybody. Okay, so in this video we are looking at maximization and minimization problems. So in the previous video we were looking at how to find the maximum minimum point of a function, but now we're going to look at the real life scenarios for it. So maximizing and maximum and minimum problems in calculus involve finding where a function reaches its maximum or its minimum, so its highest value or its lowest value. They're widely applied, right, to like practices like in economics. Is used a lot in economics, and maximizing profits. It's used in maximizing like area, minimizing costs, optimizing dimensions for objects or shapes. So max and min problems, right? Big block of texture, how to do them. But honestly, there's no point reading all this. So it's just tips you need, right? So make sure, draw a diagram, right? Always draw a diagram if you have one, right? If you have an equation with two variables in it, see if there's any way, can I maybe rewrite it with just one variable, you know? And then differentiate what you're looking for and let it equal to 0. You solve for the values, and then you sub it back in the original function to get the maximum value or the minimum value of said function. Then use your second derivative test to determine if it's a maximum or minimum. Right? So let's have a look at this one here. Liffey Appliances is marketing a new washing machine. It determines that in order to sell X machines, the price per machine in euro must be 440 minus 0.3x. It also determines that the cost in euros of producing X washing machines is given by 6,000 plus 0.5x squared. So if X machines are sold, find or X the total revenue. So revenue, well, I have my function here, right? This is how much one of them costs, right? Or not cost, but this is how much they sell them for, right? The price per machine, right? And if I sell X amount to them, it is 440 minus 0.3x times X. Therefore, my revenue function is equal to 440x minus 0.3x squared. So find P of X, the profit function, if X machines are sold. So the profit would be my revenue minus how much it cost me. So how much money I made minus how much it cost me. So my revenue function is 440x minus 0.3x squared. And I subtract my cost function here. And I'm left with minus 0.8x squared plus 440x minus 6,000. Third problem, how many machines must be produced to maximize profit? That's the key word, maximizing profit, right? Therefore, I need to find the first derivative, let it equal 0. So my first derivative here would be minus 1.6x plus 440 is equal to 0. Minus 1.6x equals minus 440. Minus 440 divided by 1.6 minus 1.6 is x equals 275. So in order to maximize my profit, I need to sell 275 machines. So let me just do my second derivative test just to make sure this is minimizing it. So if it's maximizing it, my second derivative should be less than 0. So my second derivative will just be, would you look at that? It would just be minus 1.6. And is that less than 0? Yes, it is. Therefore, it maximizes. So what is the maximum profit? Well, if 275 machines are sold, what's my maximum profit? Sub it in. So my profit function, again, is minus 0.8 x squared plus 440 x minus 6,000. Sub in 275 for x, and I get 654,500 euro. That's my maximum profit I could make on these machines. Right, let's look at another one now, but this time area and volume. So this question comes from 2005. So a cone has radius or centimeters. Its vertical height and slant height has a vertical height h and a slant height of 10 root 3. find the value of h for which the volume is a maximum. So I need to find the volume, the value of h for which the volume is maximum. So I'm looking for dv dh. Let it equal 0. Oh. So step 1, draw a diagram. Here's my diagram of a cone. My height is h, my radius is r, my slant height is 10 root 3. I have now the volume of a cone, which is 1/3 pi r squared h. However, I cannot differentiate this and let it equal 0 because I have 2 variables in here. So I need now to only have h's here. In order to only have h's here, I need to find somewhere else in this that I can write h in terms of r. But what I notice here is I can use Pythagoras. I can use Pythagoras' theorem here. So a squared plus b squared is equal to c squared. So h squared equals r plus r squared is equal to 10 root 3 squared. So r squared is equal to 300 minus h squared. So I now have what r squared is equal to. I sub that in my volume formula and I get this. 1/3 pi 300h minus h cubed. Now I need to differentiate the volume with respect to h. So I'm going to have here 1/3 pi times 300h is just 100h pi, or 100 pi h, I should say. And then this will just be minus 1/3 pi h cubed. So dv h is equal to, well, this will just be 100 pi. And then 3 times minus 1/3 is just minus 1, minus pi h squared. H squared is equal to, and let it equal 0. So 0. So I solve now for h. So I'm going to have 100 pi is equal to pi h squared by both sides by h. Boom, boom. I get 100 is equal to h squared. H is going to be equal to 10 centimeters. So my volume of a cone maximizes when my height is 10. And it will still have the same amount of height. So when h is 10 gives a maximum volume of the cone. So the volume, in this case, we sub it back in now to my formula up here. And I will get 2096.79 centimeters cubed. Right, so that is maximizing and minimizing problem. They're kind of the two types you'll kind of come across: profiting by profit and loss, and area volume. So let's look at some more questions here. So this one is 2015. So this one's tricky because we have a trig function here. So the approximate length of the day in Galway, measured in hours from sunrise to sunset, may be calculated using the formula 12.25 plus 4.75 sine 2 pi over 365t, where t is the number of days after March 21st, and 2 pi over 365t is expressed in radians. Find the length of the day in Galway on June 5th, 76 days after March 1st. So I'm looking for f of 76, which is 12.25 plus 4.75 sine 2 pi over 365 times 76, which should roughly, wow, ooh, accumulator, 12.25 plus 4.75 sine I over 5, 6 is equal to 16.84 hours, but it says correct to the nearest minute. So it's 16 hours and 0.84 of a minute. I say 0.84 of an hour, so multiply that by 60. 0.84 times 60 is equal to 50. So 16 hours and 50 minutes. Fine. find the date in which the length of the day in Galway is approximately 15 hours. So I just now want to find a date where the length is 15 hours. So it's just 12.25 plus 4.759 2 pi over 365 t equals 15. So 15 minus 12.25 and divided by 4.75 going to give me sine of 2 pi over 365t equals 11 over 19. So sine inverse this. I'm going to get 2 pi over 365t is equal to 0.6174 multiplied by 365 divided by 2 pi t is equal to 35.87 days. To find a date which, so this is going to be roughly 36 days after March 21st. That's a mean question. Thank God, I don't know my days. Okay, it's 30 days of September, October. Okay, you're just going to have to trust me on this, but 36 days after March 21st is April 26th. Right? Very, very, very mean question. Find f of t, the derivative of f. So this 12.25 goes to 0, and then this sine goes to cosine. So it's plus 4.75 cosine 2 pi over 365t multiplied by the derivative in my bracket, 2 pi over 365. So that is going to give me 19 pi cosine 2 pi over 365t all over 730. So hence or otherwise find the longest day in Galway. So first derivative equals 0. So 19 pi cosine 2 pi 365t all over 730 equals 0. So multiply across by 730 divided by 19 pi. I have cosine 2 pi over 365t is equal to 0. 2 pi over 365t is equal to cosine inverse of 0. And cosine inverse of 0 is equal to a half pi. So multiply by 365 divided by 2 pi dash. So we get t is equal to 91.25, and then I need to sub that in f of t, my original function, 91.25, so it's 12.25 plus 4.75 sine Then T was 91.25. Put that in my calculator. I get 12.25 plus 9 to 2 pi 365 times 91.25 roughly equal to roughly equal to 17 hours. Heavens, that was long, right? That was equal to 17 hours there. Right, let's look at another one here. This is from 2013. So a stadium can hold 25,000 people. People attending a regular event at the stadium must purchase a ticket in advance. So when the ticket price is €20, the expected attendance at the event is 12,000 people. The result of a survey carried out by the owner suggests that for every €1 reduction from €20 in the price, the expected attendance would increase by 1,000. So if the ticket price was 18, what would you expect to be the expected attendance? So the price is 18. So that was a €2 deduction. Therefore, according to this model here, for every €1 reduction, it's meant to increase by 1,000. It'll be increased by 2,000 people. Therefore, 12,000 plus 2,000 is equal to 14,000. Let X be the ticket price for X less than 20. Write down a formula for the expected attendance of a game. So I'm going to say EX, the attendance. Well, that would be 12,000 plus €20 minus ticket price, then times 1,000. Right? Because whatever the ticket price is, if it's reduced by €2, then we're adding 2,000 people, etc., etc. Write down now a function that gives you expected income on ticket sales. So let me finish this one off here. Expected attendance is going to be equal to 12,000 plus 20,000 minus 1,000x. So 32,000 minus 1,000x. Write down a function f that gives you expected income with the sale of tickets for such an event. So this is the attendance and ticket price is X. Therefore, my profit will just be, or my times X. So my expected income will be 32,000 X minus 1,000x squared. And finally, find the price at which the ticket should be sold to give them maximum expected income. So let that equal 0. That is going to be 32,000 minus. Bring the power down. 2 times 1,000 is 2,000. X equals 0. X is going to be equal to 16. Right, so when X is equal to 16, that is when it will be at a maximum. Then find the expected income. So find the expected income here. Actually, let me just do my little second derivative test to double check. So it should be less than 0 if it's maximum. And the derivative of this is minus 2,000, which is less than 0. Therefore, it's a maximum. Stunning. Right, what's the maximum expected income? Sub it in. P of 16. 32,000 times 16 minus 1,000 times 16 squared. That is going to be equal to 250,000. Right, let's look at this one now. We have two questions left. So, a company uses waterproof paper to make disposable conical drinking cups. Make each cup a sector A O B is cut from a circular piece of paper of radius centimeters. The edges AO and OB then join to form a cup as shown. The radius of the rim of the cup is R, and the height of the cup is H. By expressing R squared in terms of H, show that the capacity up in centimeters cubed is given by this formula. So, well, if we look here, the rim of this cup is going to be 9. So I can use Pythagoras' theorem. 9 squared is equal to R squared plus H squared. And R squared is going to be equal to 81 minus H squared. And now the volume of a cone is equal to 1/3 pi R squared H. Well, R squared is 81 minus H squared. So V is equal to 1/3 pi times 81 minus H squared times H. The volume is going to be equal to 81 pi over 3 minus 1/3 pi H cubed. Find the maximum possible volume of the cup. Well, dV dH is going to be equal to, well, that goes to 0. No, sorry, that's H there. So, sorry, there's a H in here. Forgot to multiply in. So, that's 81H minus H cubes. H goes there. I do apologize. dV dH. This goes to 81 pi over 3. And this here just goes to 3 times 1/3 is minus 1 pi H squared. Let it equal 0. So 81 pi over 3 is equal to pi H squared divided across by pi. Square root both sides. I get square root 81 over 3, which is equal to 9 over root 3, which does, in fact, actually simplify to 3 root 3. So my height is equal to 3 root 3. So sub that into my volume. My volume is then equal to 1/3 pi 81 minus 3 root 3 squared times 3 root 3. That shall be equal to 294 centimeters cubed. And that is the maximum volume of the paper. Right, another one. Right, gotta keep going. Right, 2019. Norman windows consist of a rectangular topped by a semicircle, as shown above. Let the height of the rectangle be y meters, and the radius of the semicircle be x meters, as shown. The perimeter of the window is p. The Norman window shown above has a perimeter of 12. And y equals 12 minus 2 plus pi x all over 2. Show that the function ax equals 24x minus pi plus 4x squared all over 2 represents the area of the window in terms of x and y. Well, we need to find the area here. Well, this rectangular area is just equal to x, not xy, because this is going to be x as well, so that's actually 2x. So this is actually, the area is going to be 2xy, and then it's a half pi or squared. In this case, or is equal to x. So let's shove it in. It's equal to 2xy plus a half pi x squared. So y is equal to, so be 2x times 12 minus 2 plus pi x all over 2 plus pi x squared all over 2. That's going to be 24x minus 2 plus pi. X times 2x is 2x squared plus pi x squared all over 2. So I'm just going to be left with here 24x minus 4x squared minus 2 pi x squared plus pi x squared all over 2. That would be 24x minus 4x squared minus pi x squared all over 2. Factor out the x squared here because it needs to look like this up here. But factor out a minus x squared, I have 24x minus, and that would be pi plus 4x squared all over 2. There you go, I've proven that there. Bit of a long one, sorry. Find the derivative a of x. So we're differentiating with respect to differentiating with respect to x. So I can just differentiate so take it to half here. It's so multiplying the half is 24x divided by, no, but dividing the 2. 24x divided by 2 is 12x. Then that's going to be minus pi plus 4 over 2x squared. Now let's differentiate it. 12x goes to 12. And then 2 brings down here, cancel out the half. So it'll be minus pi plus 4x. There we go. Find the relationship between x and y when the area is at a maximum. So the area is at a maximum, the first derivative equals 0. So x is going to be equal to 12 over pi plus 4. And if you do that, you get x is roughly equal to 1.68. And if you look here, for x equals 1.68, y equals, let's find what x is. Y is equal to 12 minus pi plus 4 times 1.68 all over 2 minus 2. It's minus 2 plus pi, is it? Yeah, minus 2 plus pi. Put that in our calculator. Y is also equal to 1.68. They are the same. X and Y are the same. So, right, last question here. 2020, leaving to higher level, paper 1. A rectangle is inscribed in a circle of radius 5 and a center 0, 0, as shown. Let or xy, where xy is real numbers, be the vertex of the rectangle in the first quadrant shown. Let theta be the angle between O or and the positive x-axis. The point or can be written as A cosine theta, B sine theta. Find the values of A and B. Well, so if you look here, right, if you look here, this is going to be my y value, this is going to be my x value, right? Because this is my vertical height, this is my x down the corridor, up the stairs. So, Takatoa, so I'm going to have here sine theta is equal to y over 5. 5 sine theta is equal to y. And I have cosine theta is equal to x over 5. So 5 cosine theta is equal to x. So therefore, A and B. Show that the area of the rectangle measured in square units can be written as 50 sine theta. So the area of this kind of rectangle is x times y, where x is 5 cosine theta, and y is 5 sine theta, and it kind of times it all up by 4. So I'm going to be left with 4 times 25 cosine theta sine theta, which is equal to 100 cosine theta sine theta. Now, something interesting to note, sine 2 theta is equal to 2 cosine theta sine theta. This is one of our trig identities. Therefore, 50 sine 2 theta is going to be equal to 100 cosine theta sine theta. Therefore, this can be written as 50 sine 2 theta. Stunning. Use calculus to show that the rectangle with the maximum area is a square. So I need to differentiate this and let it equal 0. So solve for the angle here. So that would be equal to 50 cosine 2 theta times the derivative of the angle is equal to 0. 100 cosine 2 theta is equal to 0. Cosine 2 theta is equal to 0. 2 theta is equal to cosine inverse of 0. 2 theta is equal to 90. Theta is equal to 45. And if theta is equal to 45, where we look here, x, y. So 5 cosine 45 and y, it's like 5 cosine, it's like sine 45. Right? If you put them in your calculator, you're going to get the same thing. So 5, that's going to be equal to 5 root 2 over 2. And that's also going to be equal to, so x is going to be equal to 5 root 2 over 2. And y is going to be equal to 5 root 2 over 2. So x and y are the same. Therefore, it is a square. Right, then find this maximum area. Well, we just know the area happens when the angle is 45 degrees. Sub it in, 50 sine 2 times 45, 50 sine 90, 50 times sine 90 is 1. The answer is 50 units squared. That's it there. And that is maximum minimum problems. I hope this video was some sort of help to you. God, my voice is gone, and probably rambling a bit and wasn't making a lot of eye contact. I do apologize. I hope this video was some help, and I'll catch you guys later. Bye.